Hello, I'm SolarLoon, and this video should be in full HD, completely capturing my entire desktop at a nice little smooth frame rate, a nice clip. I'm using a nice little compressor that I found for VirtualDub. I think it's H264, something like that. Really small files, really smooth capture, really quick. It's beautiful. Okay, so we're getting back to this. We're getting back to 2D sprites in the BGE. I haven't made this tutorial in so long. I haven't worked on this, but basically I'm trying to get back to it now, basically because I'm realizing that it's pretty simple, and most of the things that I really need to go into, I don't need to do it all at once. I can do it in incremental parts like I've been doing, but smaller parts, as well as it shouldn't be too difficult. It shouldn't be too difficult to do. If it's too difficult, then I should just stop and really say I'm not going to do these tutorials anymore. But if I can get it to be simple, then I can continue doing it. Alright, so this is a pretty simple thing here. We had our player. He's walking, he's animating. You walk off a ledge, he falls. Okay, so the first thing you'll notice is on the left side of my screen, I have a completely different editor. I have Komodo edit as opposed to Genie. Komodo edit is heavier. It's kind of harder on your CPU, on your resources rather. So you'll sometimes come back, let's say from coding yesterday, and leave your computer on and come back and click on Komodo edit, and it'll take a little while to come back up, and it's kind of heavy, little things like that. But it's a nice solid editor. It has code completion. It has a lot of nice features. It's really readable. It has a project viewer, as you can see over here, which holds your Python files and your Python files, your code files, as well as the ability to manage views into for example, include or exclude files from the project viewer here. So I'm going to go into the Komodo edit, using Komodo edit, kind of setting it up really quickly. I'm going to do that on a different video, or I guess by this point we'll have done it on a different video. So this video we'll just basically jump right in. Alright, so basically what we're going to do is just clean up our code. I had this recorded before, and I tried to do this and adding in a jump, and it was just it was really long and really kind of haphazard. So we're just going to clean up our code a little bit and really improve how our code executes. And that's kind of a major part of game development, is really making sure your game is fun to work on. And if it's not fun to work on, if it's kind of boring, or if it's kind of hard to work on, really unmanaged and unorganized, you're going to get discouraged. You're going to be saying, oh, I should have made that, all of these objects share a function, or I should have made, I should have, implemented optimizations by now. And so you don't want to get to the point where it's a pain to work on something. So if something really doesn't look good, and if it doesn't work well and it's not elegant, you should pretty much go back and try to get it and chip it down to something simpler, easier to read, easier to implement, easier to maintain. So that's what we're going to be doing. So let's see what we got here. We got our key down function. It really doesn't need to be in the player function at all. And that's kind of you know what we're going to do is completely separate these out, because it really doesn't need to happen that the player function contains functions. I'm not sure if it's bad Python form, but it really doesn't make sense, and it's not very easy to see that you have functions inside of functions. I think it is bad form because it's constantly redefining the functions. It doesn't hurt the FPS pretty much any noticeable amount, but it's easier to see if you separate things out. So what we're going to do is just go ahead and move the key down function out. So we have our key down function separated here. Now let's see, we have the logic.keyboard.activeEvents dictionary, and that contains our keyboard values, our keyboard key codes that we're pressing. Now the active events dictionary is probably useful for things that you don't know, or for situations where you don't know which key is being pressed. Like for example, if you were emulating a terminal where you could type in values and type in commands and press enter and have it execute that in the game, then you might use the active events dictionary, because you can basically just look through the dictionary and see which keys are being pressed. So that's great. But for our game where we know which keys are being pressed and we're constantly polling for them, it really doesn't make sense. So what we're going to do is just use the keyboard.events dictionary. We say if keyboard key code is equal to logic.kx input active, return 1, and that would obviously stop the, or that would stop the function when we return 1. And if it's not true, then it continues until return 0 is reached. So we don't need an else statement here for the event that the keyboard key code value, the keyboard key code, value isn't active. All right, so that's our key code. Key down function here. So now what we're going to do is go ahead and move the init function out of the player function. It really doesn't need to be there, like I said. We're just kind of making things easier to see. So the player init function's up here. We're going to move the player update function up here. And we're going to move the player's animate function up here. All right. Make sure we rename it. Okay. We're going to move also the animate function out of the update function, or rather the animate function call out of the update function, and we're going to move it down here. Player animate. Okay. So we have the player's init function. We have his update function. We have his animate function. All separated out. All separate. Now you might have noticed me doing something with the tabs, with the tabs here. What you can do is just quickly, too quickly, adjust the tabs of each line. You can press Shift Tab or Tab. Oops. Shift Tab or Tab to adjust the tab levels. So that's useful if you need to adjust a whole block at a time, like I'm doing here. Okay, so we have our functions separated out. We can go ahead and add some white space, some free lines, not that much, but just something to make it, again, more readable. You want to make sure that it's not ever hard to read, and we'll notice that the game doesn't work. So let's see why. All right, it's because OBJ isn't. Because that is because OBJ isn't declared. So we want to go ahead and declare this in all of our functions. You might notice, it still won't work, and that is because where is OBJ getting the object reference from? Well, from the controller. But where's the controller being supplied to? Nowhere in each function. So what we're going to do is just pass the controller so that we have access to the controller as well as the object. Even though we probably won't be using the controller itself right now, we can just go ahead and set that up for later. Alright, so it should work. Let's go ahead and try it out, and it does. Alright, so everything's good. He falls off the edge, everything's good. So let's go ahead and continue to clean up our code. Alright, so we did the key down function. Okay, so the init function. This is for initializing variables and initializing object, initializing variables and things. So one thing we have here is the sprite variable, and that is using a list comprehension so that we grab the sprite of the player object, which is this object, this plane. Now, something that I usually do is this kind of system where I look for the objects, through the object's children, through the parent object's children, and look for a string in the child's lowercase name. That's really unnecessary, and it really just does make it harder to read, and it's kind of a style thing on my part rather than something I would recommend other people to do. I just don't want it to be the case where, for example, I misspell player SPR and use a lowercase s, and then the script doesn't work and I don't know. That really won't happen because you can see it's not finding the child. The string you're searching for isn't there in the child's name. Put it two and two together, and you're going to come up with the fact that I misspelled the name. So we're just going to say C for C in obj children. So for all the children in obj.children, add them to the list, to this the list kind of represented by these two brackets here, if SPR in C.name. Okay, you could also do if C.name is equal to player SPR. You could also do if sprite in C, and now that is basically, that system is searching for a variable inside of an object rather than a variable in the object's name or other property. So when we say if sprite in C, what that means is the object, the sprite, or whatever child we're looking for, has to have a sprite value variable. So I'm gonna just create it really quickly again. A sprite value variable in the object. It doesn't matter what type it is. Any type is fine, but it has to be there. And then we could search for the object like that. So that way you don't have to really worry about misspelling the name, and you can just worry about misspelling the variable, which is more likely that you're going to spell correctly. Okay, so we're getting the first object in that list, which is fine. We're making a dictionary of animations. We have the walk dictionary and the stand dictionary. I'm sorry, the walk animation list and the stand animation list. I don't really like the system that I had because you can't really fine-tune the animation speed. Like, for example, if we wanted to play the animation faster if he's moving faster, or slow it down if he's moving slower, or different things like that, you can't really do that because of the way it is, where the FPS is hard-coded into the animation list. So that's what we're going to basically change. We're going to just have the animation list itself for each key in the animation dictionary. We have our key bindings here. It would probably be best to define that in a system file, or in a system area, because this obviously gets defined every time we create we initialize the object, which is obviously not really a good idea. In case you have something like key bindings for an option screen, then you could obviously load up the option screen, have the player set his key bindings, and that would hold throughout the game. So you probably wouldn't want to have the key bindings here in the actual player object, but that's kind of a discussion for another day, or just an implementation for another day. Okay, so that's pretty much it for the player initialization. Let's look at the player update. Now this is like the worst the worst of the worst in terms of how this works. It's really complex. It doesn't really work. It works well, but it doesn't work. It doesn't look good it's not understandable, basically. You want to make sure that your code is understandable, and if there's an error, it's easy to solve. So that's what we're going to be doing today, is making sure that our code is easy to solve. So I'm going to comment this out, and you press Control 3 or Control Shift 3 to Control 3 or Control Shift 3 to add to comment things out. And we're also going to comment that out. Okay. So now what we were doing before, I'm going to walk through this, is first we get the object's world velocity, which we will be doing with the object's world linear velocity. That was added in a recent build of Blender. I think 2.66 added this, or possibly a little bit before that. So you can just use obj.world_linear_velocity.copy. Now, copy is a property. I'm sorry, copy is a function that's available on vector properties. So you can check the API to see what a vector can do, but a vector, you probably know already, but a vector is just basically a velocity and a direction. That's what a vector is. It's the velocity and a direction indicated by a number, or a set of numbers, x, y, and z, for a three-dimensional vector. So we're going to copy that down, because we're not going to be using a reference, and we're going to be altering that. Now, the difference between a reference and a copy of a reference, or a copy of a vector rather. A reference, if we were to just do this, we would be actually hand setting the object's world linear velocity like that. So if mv is the object's world linear velocity, then setting mv.x to be 100, that actually moves him 100 Blender units a second on the x-axis, positive. That's what that will do. If we add .copy, then we're altering the copy of his world linear velocity, and this won't actually move him. We have to set it back with obj.world linear velocity equals mv. That's what we would have to do. So we're going to go ahead and leave that there. We're going to set the mv.y to be 0, and we're going to set the mv.z to be 0. Now the y is so that he doesn't move on that y-axis, which is also indicated here by the world position.y, setting that to be 0, so he doesn't shift forward and back. So that's good, because if something were to like kind of shear into him, something round perhaps, it might push him forward or back. You could try locking him on the y-axis with lock translation, but it might just lock the actual motion on the y-axis, not actually lock him physically to his position on the y-axis. So this is to just ensure that he doesn't move on the y-axis, and he also doesn't shift on the y-axis. Or he doesn't actually, rather, he doesn't get any speed on the y-axis, and he doesn't move on the y-axis. And you might be wondering, well, why do you have this when you obviously are just setting his y position directly here? Well, you want to make sure that his speed doesn't change, on the y-axis. You don't want his speed to be, gaining momentum or going willy-nilly, so to speak, while he's being shifted or locked to a grid position or locked to a y position, because that will cause some inaccuracies and problems with the physics engine. So you want to make sure that you set the y-axis speed to be 0 and the world position on the y-axis to be where he should be, which is the center, 0. Alright, so what we're going to be doing here, this is a nice little trick. You can say mv.y, mv.z. Notice the comma. You can do this in Python, basically allowing you to set multiple values at a time. So we're setting his y and z speed at the same time with wait, what? Oh, that's right, I have to fix that. Okay, we're setting his y and z speed at the same time using this kind of unpacking method, where we set his y and his z to be his 0 and 0, and it works in place. So the first 0 is for y and the second 0 is for z. Now you might have noticed that we had some errors here. That's because our animate function is still looking for the FPS, or I'm sorry, it's still looking for the animation to be in a list. But if you remember, we moved that out. So what we're going to do is just quickly fix this so that we don't we can continue working on this. So basically, what I moved it out of basically I moved it out of the animation dictionary because this way you can have more control. So we're setting the SPR-FPS variable. We're making it right now, and we're setting it to be 6 if he's walking and 12 if he's standing. We don't need to access the animation as a dictionary. I'm sorry, as a list rather anymore, where the first index was the animation and the second one was the FPS. Now we access it directly, the animation dictionary, with the animation we're looking for. Accessing that dictionary to get the animation here. So obj anim walk, we're accessing the walk animation, and the FPS is set up here, where we manually set the animation values. I'm sorry, the current animation. Okay, so that should be it, and yeah, everything's good. He's animating. Nice. Okay, so let's go back over here. So remember this making a new vector for adding friction? That's absurd. But yeah, that's the way I was doing it. I was really it worked, but it was not elegant. So you want to make sure that your code, like I said, is readable. It works well. So what we're going to do is just go ahead and basically do this again. We're going to say mv.magnitude minus equal obj friction if mv.magnitude is minus obj friction is greater than 0, else mv.magnitude. And you probably remember what this does. If his magnitude minus friction, subtract friction from the movement vectors, his world linear velocity rather, that magnitude, if it will be above 0. Otherwise, then subtract it by itself and leave it at 0. Vectors, you cannot set magnitudes to be negative. That's something to kind of keep in mind. If you set the magnitude of a vector to be negative, it will throw an error. So that's, you can't do that. Alright, so we are adding in the friction there. And now we say if keyed down, should be still here. Yep, it is. That's a little autocomplete that Komodo edit does, because it knows what the key down function is and knows it's up here. And it also works across Python files, so you can say, for example, game functions dot key down or different things like that. And you notice this little red line, that means that my code is going to throw an error. It's a syntax error. And so basically, I can't leave it like that and expect the game engine to run it, or expect Python to run it, to compile it, or run it. Yeah, it doesn't compile things. Compiling things isn't what causes the errors or shows the errors. It's when it interprets the Python. So anyway, if your key is down and we're looking for obj kb left, mv.x minus equal obj excel. Else if key down, obj kb right. Oops. mv.x plus equal obj excel. Okay, so let's see how that works and if it works. It does. Now you pretty much notice immediately he speeds off at an incredible rate. That's because we haven't capped his maximum speed yet. So let's try that. Now before, basically we would say mv.magnitude equal obj max speed if mv.magnitude is greater than obj max speed, else mv.magnitude. So if his magnitude of his movement vector, movement speed rather, is greater than maximum speed, set it to be that, cap it to be that. Otherwise, leave it alone basically. Now this you might think, oh well, that will work, but the problem with that is he can never exceed his maximum speed no matter what. So, if he's hit by a platform, if he's on a car, if he's, whatever, he will never exceed that maximum speed. And that's not really what you want. What you want more so is for him not to exceed his maximum speed if he's walking. Under the player's control, you can't move right or move left faster than, the movement speed allows you to. The maximum speed, rather. The maximum speed variable allows you to. So what we're going to do is add that into the key checks instead. We say if he's pressing left and mv.x minus obj excel is greater than negative obj max speed, then do that, and rather then continue. And if he's, or otherwise, if he's pressing right and mv.x plus obj excel is less than obj max speed, then mv.x plus equal obj excel. So if he's pressing left but he's already at full speed, then basically it shouldn't add acceleration to his movement speed. And the same thing for right. If he's pressing right but he's already at maximum speed, then don't accelerate anymore. Now friction will automatically tone that down so that basically he will always be almost at the brink of going faster, but friction will automatically slow him down. In the next frame he'll be slowed down enough, probably, or he should be slowed down enough to speed up again. So it's pretty simple. It works pretty well. It's not really surging or anything like that. It's a nice smooth motion, and the good thing about that is that he should be able to move on the x and y x-axis, and be locked to a maximum speed while still being able to get on a platform that's moving faster or do different things that would actually change his movement speed. So you notice that he sinks down really slowly. That's because the mv.z is set to 0. The z-axis, I find it easiest to just kind of treat the z-axis to be kind of like cool. I find it best to basically treat the z-axis as a special case where essentially what you want to do with the z-axis is leave it alone, leave it at 0 until you press jump, and then spike it for that one frame. Then in the next frame it can stay at 0 because gravity will take over. So we're going to be basically treating mv.z as an impulse kind of approach, whereas mv.x is like looking at the actual speed of the game object. We're going to basically, we're just disregarding the z-axis movement of the world linear velocity for now, and then once we're done with the friction and maximum speed here, then we can go ahead and add in the z back, the vertical speed back. So we say mv.z equals obj.world linear velocity dot z, and then we set it back. So it's pretty simple. It kind of seems roundabout, but it works well. So we say disregard the z-axis, add in friction, check for input, put the z-axis movement back, and then apply the world linear velocity all together. X, Y, and Z, even though we're disregarding Y, and Z is unchanged. So basically, if we were to make a jump, it would go after our input, our friction and maximum speed checks here. Right here would be the jumping, or right here would be the jumping, after we set the mv.z variable back. Okay, so that's pretty much it. It's a nice kind of simplified version, a lot easier to look at. It's not nearly as many lines. The lines aren't nearly as long. Pretty simple overall. Yeah, so that's kind of what you want to do when you're making a game, is just make sure that your code is well commented, but mostly easy to look at, easy to see, easy to read. Komodo edit is a nice editor because it allows you to do things like fold your code, so you can fold up what you're not looking at. We probably can rename this to player main, just so that we don't have such a kind of discrepancy in how not discrepancy, but just kind of, we don't want to have a generic function name like player main, player dot player, player Python file, player function. I mean, you want to kind of give yourself an entry point, tell yourself what you're looking at. Okay, so yeah, that's basically it. That's basically the system. So it's pretty simple. Looking at this, it looks very componenty, doesn't it? It looks very much like we have an update component, we have an animation component, we have an initialization component. So that's kind of something else I want to get into, is kind of component-based game design. I'd like to make a video on that. I'd like to make a video on class-based game design as well. Or rather, class-based coding with the BGE. Well, kind of class-based, because I wouldn't talk about how to actually override the game object, the normal game object class with your own class. You can do that, but I would more talk about how you're kind of already using classes when you work with the BGE. And basically, no matter what, you're always using an instance of a class, an object. A game object is an instance of a class, and since you can create more than one, it also serves as a class itself, because you can duplicate objects and make more, and they all perform the same way. So I'm kind of going to go into a little bit of that and kind of sharing code, or rather I would at least like to. And the next tutorial, I'd like to do that, or component based game development, game coding. So just different things like that. We could also use a different input system. I'll see about maybe doing a little tutorial on that, or tip video rather. No more tutorials for me, just tip videos. Okay, well, that's the part 3 of our 2D Sprite tutorial. This has been just kind of cleaning up our code, refactoring it a little bit, making it easier to read and nicer to look at. Thank you very much for watching. I've been SolarLoon, and hopefully you'll have fun making games, 2D, 3D, whatever, with the Blender game engine. Have fun.